Of LEETCODE question 378, case smallest element in a sorted matrix. Given an n plus n matrix where each of the rows and columns is sorted in ascending order, look at this matrix here. It's 1, 5, 9, 10, 13. Everything is sorted already. So it's something look like this, and it's matrix, and n plus n here is 3 plus 3 here, and return the smallest element in the matrix. Note that it is the case smallest element in the sorted order, not the case distinct element, because there could be some duplicate here. They don't need you to return the non-duplicate, and basically it's include all the number, include the duplicates, and then start counting k equals to a. And in this example, you want to count the eighth number, 1, 2, 3, 4, 5, 6, 7, 8. So the eighth number is 13, and then you return the output is 13. And in this example, the matrix k equals 1, and it's minus 5, and the output is minus 5. If you look at this matrix here, you always want to find the case smallest in this matrix. And the way you think about it to solve this problem should be using something as a minimum heap. And because the minimum heap that you can continue to pop the smallest value from the minimum heap, and you want to pop the k times. And the only thing is that how do we handle this in a matrix situation? Because there's different rows and different columns here, right? So at the beginning, what you want to do is you want to add the smallest number. So basically, you want to add number 1, and it's at zero row and a 0 column. So basically what you want to push into the minimum heap is the number itself and the row index and the column index. And the reason that we want to pop the row index, the column index, is that after we pop out the smallest value, we want to push the next value into the minimum heap. And how do we know which next value to push into the minimum heap, right? In this case, so at the beginning, what we want to push into the minimum heap is 10, and then 1 index column is 0, right? And then we want to pop into the minimum heap as number 12, and the row index is 2 and column index is 0. After we have these 3 numbers, and we want to start popping the smallest number, which is the 100. And after we remove the 100, what we want to add into the minimum heap is the next number, because remember that we popped is 100, right? So we remember the row index and column index. We want to make sure that we pop from the same row, but the column is plus 1, the previous column number plus 1. So basically we want to push into as 5, and then the row is 0, but the column is 0 plus 1, which is 1 in this case. And after we push the 5 into this, so we compare the 3 value, 5, 10, 12. Okay, 5 is the smallest, and then we want to pop 5, right? And each time when we pop out the value, we want to decrement the k, because we want to find the k smallest. And then how many times we already popped? We popped the 1, right? And then we popped the 5. And then the next time, what we wanted to do is, since we popped from 5, the number we pop is 5, we also want to make sure that we pop from the same row. Basically, it's the next number, which should be 9 in this case. It's also row 0, but the index is 2 in this case. And then we compare, we look at 9, 10, 12. Oh wow, 9 is still the smallest, so then we're gonna continue to remove 9 in this case. And then the next value that we want to go through is the rest of the list. And then the idea is that we want to decrement k every time when we pop. And so when we pop the k's time, that's the kth smallest value that we're looking for. So let me show you how to do this in code here. So we want to create a minimal heap first, right? And then for row and range, so the range of the rows that we wanted to do a minimum of it's either the k or the length of the matrix. The reason is because if this k is smaller than the length of the matrix, then we don't need to go through all the numbers pop so many times. So we want to make sure that we append the minimum heap value. What we appended is the matrix, the row number, and the column. We want to start from 0, right? And then the row number and the column number. This is the beginning. Basically, after this step, what we pop into the minimal heap is the number 1, and then the row and the column, and then we also appended the number 10 RC, right? And then we appended a 12 RC. It's the smallest because all these array are sorted, so we appended all 3 smallest value into the minimum heap after this for loop, right? So then the next thing we wanted to do is we wanted to check the k. While k, we want to while k exists, and we want to decrement the k. So the result that we are looking for and the row and the columns are actually equal to heapq dot heap pop. So we basically pop from the minimum heap, and then the value we pop out, we will get a result, which is the number and then the row and then the column, right? That's what we are looking for. So if the column is smaller than the length of the matrix, -1, right? If the column is smaller than the entire length, then the heap q, and we wanted to do is heap push into the minimum heap. What value do we want to push into the minimum heap is actually the matrix. The matrix that when we did remember in the explanation, because we popped out the 0, we popped out the 1. So the next one we want to push into, the value we want to push into is in the same row, but the column is +1. So basically that we want to push the same row, but a column +1, if that makes sense. So then the row is still row, right? But the column is C +1 in this case. And then after that, so we go through all these. After we add the number, we want to make sure we count decrement k each time when we do this, we pop. So then while k equals to 0, then we can return the result that we are looking for. We don't need the row or the columns. So that's all the code. Let's see. Okay. It accepted. I hope this is helpful. Let me know if you have any questions. If you like, please like the video and subscribe to my channel, and I'll have more LeetCode questions for you coming soon. Thank you. Bye-bye.